Hi, hello everyone. Uh, welcome you everyone again for an session of talking with Space Kids India. So here we are in the final phase of the docking. What we call is as the final translation phase, where we get close to the International Space Station. And as I said before in yesterday's um, talk, as it gets straight in the same uh, orbital area of the International Space Station, it slowly gets close to the International Space Station by using the thrusters. So this is at this phase. Here we can see that the few lights are blinking because they use technology such as laser to correctly target to point the target and to dock with the International Space Station. And if you have any doubts, please go ahead in the live comments. I'll be happy to answer. Rifat Bro will join us soon. He is a little busy with other live. Can anyone, if you have any doubts, please post it here. So, yeah, until other people join us soon, we will keep talking about the mission specification and how excited we are. We are gonna see about the we're gonna see soon the talking of the Dragon capsule at the International Space Station, and it's gonna be an historic moment for entire space community, and of course, this is gonna be a really memorable one for each and everyone watching the live. Um, so let's see. Okay, that's a question here. What happens if it doesn't dock with ISS? So, as you can see now, mm, like they are using thrusters. So we have a window called as SF window, within which they can go and dock with the International Space Station. But in case if the at the final moments of docking, if there is a little disturbance or anomaly, and if the spacecraft, if the Dragon capsule can't go in a straight line to dock with International Space Station, what happens is it again refaces back. It comes back slowly, so it doesn't affect the International Space Station. It comes back to a safe place, and then it uses a reverse thruster to slow down to get away from International Space Station. And after some time, they again try to dock with International Space Station. Uh, so what's the distance that they like now? They are at the distance of around some 500 meter to 3000 meter. They are now trying to close with the International Space Station. Once they are close to near 500 meter, then they will go with the final transition phase. What you are seeing now, you can see the thrusters firing a different direction. You can see the thrusters firing a blow, like they are perfectly aligning with the International Space Station to dock with it. So if they don't dock, they of course they will try again. I hope I answered your question. You can see now here, you can see the International Space Station here, and then you can see our Dragon there. So it's the final phase of docking. So it will take roughly another half an hour to a few minutes to half an hour or 1 hour based on the how close they are reaching their target. I one second. There is no any update from the crew. I'm just trying to listen to them at which position they are located now. Okay. Okay, they have captured the docking maneuver. So So now there was an announcement that there was that the Dragon capsule has directly aligned with International Space Station. So now they're launching for a final maneuver phase where they can directly go and dock with the International Space Station. If you have any doubts regarding the docking process or any doubts regarding the orbital mechanics, please leave it in the comment section. I'll be happy to answer it for you. So now the Dragon capsule is moving at a speed of zero point 0.1 meter per second. That's what they say. And there is a question how much time it will take. So it may take up to another 30 minutes. I mean, depends on how fast they're traveling. So they have not yet announced the distance. I'm trying to wait for the distance. And can you explain the structure of ISS? Of course, yeah. So ISS, International Space Station, is mainly comprised of the uh, American modules, Russian module, and also the different types of. We also have a module from Europe, and we also have a module from Japan, and it's roughly the size of an football field. And if you can see International Space Station, we have a lots and first initially an International Space Station need power, and for the power system we have really huge solar panels for the International Space Station. Uh, International Space Station. And apart from the power station, apart from the power requirement, we have to orient it with respect to the sun. So for all the solar panels in the International Space Station, we have a gimbaling mechanism which always rotates in the face of the sun. And if you take, for example, like we have various laboratories in International Space Station. And to go in detail about the structure, just I'm taking an interesting document. So yeah, so the structure, as I said, first we have US modules, the Russian module, and the European module and Japan module. The US module, we have various submodules such as US as an laboratory module called as Destiny, where they do the primary research work, where they do research on microgravity and lots of stuff that can't be done on Earth, of course, because once in microgravity things work different. So they have a lot of laboratories and they keep working on that. And they have the structure of ISS also has a strong radiation protection mechanism, because in a low Earth orbit we have a strong influx of strong fluence of proton particles that's been stored by the our Earth's radiation belt called as Van Allen belts. So International Space Station is prepared in such a way, the structure of International Space Station is prepared in such a way that it protects the astronauts inside and the equipments inside from the outer radiation environment. But if you know that there was a recent news that the Earth's magnetic field is shifting, and there is a huge the South Atlantic anomaly is expanding. So if you can say, I'll just explain in detail about the space radiation. So the South Atlantic anomaly is the region between the South America and South Africa where the Earth's magnetic field is low. So what does it mean by low? Means the Earth's magnetic field is tilted. The field of line is tilted in such a way it ends in the South Atlantic region. So what is the ill effect of this is we can the radiation particles such as protons and electrons can reach really close to the Earth's atmosphere around 400 kilometers. So International Space Station, like most of the equipments, when like major equipments, they switch off when they fly in this region to prevent the failure of the equipment. And to continuing with the structure, as I said, we have a US laboratory module, Destiny, and then we have the European Research Laboratory called as Columbus. So the Columbus deals with it's an again and research module, and it provides a microgravity environment. So it's a multifunctional pressurized laboratory and attached to Node 2 of International Space Station. In the European Research Module Columbus, what they work on is like the material science, fluid physics, and life science and technology. These experiments they take care of in the European side of the sphere module. And as I said, there is a Japanese experimental module. It's named as Kibo, which means hope. So in Kibo, they what they work on is the mm, design and develop conducting scientific research activities on orbit. Of course, again, it's a research station. So this was developed by Japanese, and it was sent into space, of course. And the next module, there are nodes in between the each International Space Station structures to connect each modules. These modules are acts as an connecting structure where you can travel between the each laboratory. And as you know, since you know, the astronauts in space have to work for minimum of 2 hours a day, because this is because once you're in space, your blood is gonna rush up to your brain, which makes your bone weaker. So what happens is like astronauts have to keep working, they have to keep training their bones, and they have to keep circulating the blood towards their body. So they have to keep working. So that's why in most of the modules in the International Space Station, in few modules they have a complete set of equipments for the astronauts to work. And we have a node 2 of called as Harmony, where like same it functions as an connecting hatch between the other two labs, and they have a few resources also. And in node 3, which is called as Tranquility, we have the accommodates IS air revitalization, oxygen generation. Yeah, okay. So as in the structure of ISS, we also need a complete environment control system, because there we need a complete a proper maintenance of a air system inside the International Space Station, and the air should also be scrubbed from carbon dioxide, because we as humans breathe out carbon dioxide. So International Space Station have scrubbers which collects the carbon dioxide from the inside the hab, and it recycles with a fresh air, and they have water recovery systems. For example, each and everything minimum from everything, even water, the water vapor and everything is being recovered in International Space Station. And this is what we have in Node 3. The Node 3 also accommodates the bathroom for the cryogen and the exercise equipment such as treadmills and type of lifting devices. So we have uh, this one. We also have airlock quest, where the you like mostly you would have seen in science fiction movies, and if you have read books, science fiction books, like they come out of an airlock hatch, and then they go for extravehicular activities. So we also have an airlock quest, which is like joint between the nations. So here, the astronaut can come out of to the outside space to work on the external equipments. And the next thing with the International Space Station structure is called as cupola, which is an observation deck. So it's made of glass and it's really beautiful. And if you watch astronaut, if you Google and try to watch cupola, you can see like lot of astronauts watching the beautiful Earth from space from this cupola model. So it's from ESA, and like lots of astronauts with a huge camera and powerful resolution, they try to capture the Earth's images from this cupola. And apart from that, we also have a permanent multi-purpose module, which is the what is permanent multi-purpose module. It was between the NASA and the Italian Space Agency. So here, what they do is additional storage place. Yeah, okay. So this permanent multi-purpose module is used as an additional storage space and to look to per location to perform sign and other activities. So mostly, if you can see, most of the spaces International Space Station is completely allocated for research activities, scientific research activities. Few places for storage and few places for exercise and exercise of the astronauts. And we also have some functional cargo block called as Sunrise. And here we have the most of the controls, like computer controls, like air guides, communication panel, caution and warning system, and we have containment filters. We have container bags and fuses. So it is like an place where most of the essential equipment that's stored on with the computer access and controls. This is the functional cargo block called as Zarya, and it is launched between the NASA, Boeing, and Kubernetes State Research and Production, which is within these three, they send this module to the space, and then apart from that, we have an docking compartment. We have an update. So they are explaining that they are using some additional fuel to dock, and then they are consuming the thrusters. Okay, now they were actually explaining about the axis. So I'm just gonna explain you about the axis of the Dragon capsule, and which axis is actually gonna dock with the International Space Station, because in space the axis is different. We all know there are three major axes: X axis, Y axis, and Z axis. So if you consider an orbit, let's consider this is the satellite and this is the front part of the satellite that's flying in the orbit around the Earth. So the direction in which it flies, this is the X. This is the X direction, and let's consider the Earth is down below, and this Earth, the angle directly perpendicular to the Earth is the Z axis. So this axis is the Z axis, and the satellite is moving in the X axis. So if you consider this to be the orbit, so this is the satellite is moving in the X axis, and the Z axis, negative Z axis, is facing the Earth. So now you can actually predict which axis is going to dock with the International Space Station, because we're going to have the International Space Station here and the satellite is moving in this direction. So it's going to go and dock with the International Space Station, which means, of course, the X axis is going to go and dock with the International Space Station. And we have X, Z facing the Earth. So, which is the other axis? It's so easy to predict. The Y axis, which is perpendicular to the X and Z axis, is the Y axis. So depending on these three axes, we have the roll, pitch, and yaw, which is or like advanced concepts. So I hope you understand now, like how X axis. I mean, the docking phase is the X axis. So continuing with the International Space Station structure. So we also have the docking compartment. Yeah, okay. So now we're going to talk about the docking compartment. So we have our Dragon capsule here. It's going to dock with the docking compartment. It's being and it's mainly from the Russian segment. So here the capsule goes and docks with the compartment, and I'm just trying to read some information. Okay, so we have. So I'll try to answer how this docking procedure is done. We can see now that the capsule is placed at a certain distance from International Space Station, and it's really approaching the International Space Station at a very slow pace. This is because in space we know it's completely energy. So if in case the capsule gives a high amount of energy, what happens is it's gonna go up and shift from the International Space Station, because with higher energy it's gonna go up, and then if in case it reduces the speed, it's gonna go down, because in space it works in terms of energy. And when it gets closer to the International Space Station, there is a constant communication between the International Space Station and the Dragon capsule. So the communication is done by we have a high gain Kurz antenna, which actually makes a constant conversation between the International Space Station and the Dragon module. And we can see here, what we see here is the docking system probe, and we also have an complete laser technology, as I said before. Like completely it tries to point the docking port on the International Space Station before it goes on dock. uh, what else do we have? So yeah, I hope I said a lot, and if you have any doubt, please post it in the comment section. I'll be happy to answer for you. Just gonna listen to the audio and audio. So there is an update now that the Dragon capsule has used almost around two-thirds of its propulsion to dock. We are waiting for the further updates from the SpaceX page. So we have already used almost around two-thirds of the budget for docking. So we have one third of the budget for docking. Uh, um, Hi, Mohammed Shahil. I hope you hear me clear now. So you have asked a question how to join Space Kids India. I think Rifat Bro will come here soon to answer this question. Of course, you can still start working on the technology and start reading, because space, to learn space, to work in space, you don't have to exactly know space systems. It's like you have to know about the you have to be strong in a domain. For example, if you are stronger in mechanical, of course you're going to still work in space. And if you're strong in electrical, and you will be working on the electrical compounds. For example, here we have the dragon, uh, the inside of the dragon capsule. Here he can see all the electronic equipments working. So you'll work on the electronic equipments. So I hope Rifat Pro will be able to give a more specific answer of how to join Space Kids India. So what we see here now, it's the ground track of the International Space Station and the capsule. So what's a ground track? It's the representation of how the satellite is flying in the orbit. So in this case, you can see that the International Space Station is around 52 degrees of inclination, and this clearly represents the axis of the ground track of the International Space Station. And here they always check of how close it's reaching and at which point it's gonna dock with International Space Station. They're getting really close with International Space Station. And if you see here, there are few lines close to the from the International Space Station. You can see few lines. These are the lines of these are called as the safety influence lines. If in case the Dragon capsule exceeds this safe limit, then it's supposed to abort the mission and it's supposed to come back, and it has to dock later. It can't go ahead with proceed ahead to dock with the International Space Station if it goes beyond this certain limit of line, because then it has an higher energy, and it of course it's gonna collide with International Space Station, or it's gonna miss International Space Station, which we don't want in this case. So we always have a certain limit within which the capsule should fly, and later if in case there is any adjustment, we can make quicker adjustment to get back to normal. So it's now moving at the 3 times of a meter per second. Ah, okay. Now we have information. It's just 100 meters away from the space station. So soon we are gonna dock with International Space Station. It's just 100 meters. Just like happy. 3 tenths of a meter is like it's moving at 33 centimeters per second, well, which is like super slow, but of course it's gonna get close. Okay, so we are gonna dock with International Space Station in just another 4 minutes. Once it's near, once it's close to almost around 20 meters, it's gonna wait, and then it's gonna wait and listen for the final go no go phase. Once they give go, it's gonna dock with the International Space Station. They're zooming around the logos on the surface of the Dragon capsule. We have NASA, we have the US flag here. We are just less than 30 meters away from docking. So it's just 30 meters, for example. So on the top of the NASA logo, the three black little things are the thrusters actually. So they are in constant communication, and then we're going to dock soon. It's around almost around close to 25 meters now. They're still predicting the motion. Okay, we are going to have a sunset in less than 8.5 minutes, and then we're going to enter the eclipse phase. They have entered the phase one. They are waiting for the command of phase two to get close to the International Space Station. Now they are at 20 meters away from the International Space Station. Okay, they have confirmed to go for docking now. 1.7 meters away from the docking adapter. It's 1.7 meters away from the docking adapter. We are closing in now. So if there is any problem with the final docking phase, like when the links close in, and if there's a problem, then Dragon has to work on its abort system immediately. You can see the Dragon performing now you can see the Dragon performing minute corrections. It's getting in close. It's finally going to reach. I just hope we dock it before the sun sets. Wow. Dragon is inside 10 meters now. We are less than 10 meters away, and we are really closing in. So now the speed that we are closing in is just 10 centimeter per second, 1/10 of a meter, which is like 10 centimeter per second, which in another 1 minute 45 minutes, 1 minute 45 seconds, we're gonna dock with International Space Station. So we have the docking ports here ready to dock with the International Space Station. We are just at 5 meters away, and they're trying to finish before the sunset. So the shadow that you see now on the Dragon capsule is the shadow of the International Space Station. 3 meters to go. It's gonna be just super excited. 2 meters, and yeah, 1 meter to go. 1 meter. Come on, come on, come on, come on, come on, come on. Perfect. Come on, come on. Yeah, yeah. Soft capture is confirmed and docking is confirmed. Yeah. So perfect. Finally. Now the after docking, what we saw here was the damping mechanism that's actually acting on the soft capture mechanisms damping system that's actually acting on the capsule to make it to come attain the stabilization. We have one more step for the docking to complete. Before it was soft capture, now it has storage. So once the soft capture uh, completed, which means like once the capsule is stabilized, then it releases, and then we have 12 latches called as a hot capture mechanism, which captures the capsule and holds it in place, and then the doors of the capsule will open for the International Space Station access. So we are actually waiting for the confirmation of the hard capture now. So we can see here now the hard capture mechanism is getting ready to capture the Ryan capsule to the International Space Station. We are still waiting for the docking complete to be confirmed. So now we are going for the hot capture, and then they're gonna use hooks, 12 hooks to capture the capsule now. We are still waiting for a long time for the hard capture. So I hope it goes positive. Of course it will. Okay, so now we are actually on the dark side of the world. We are at the eclipse phase. So you may wonder from which camera are we actually looking this giant capsule. It's a camera placed in the Japanese module. and from the Japanese module outside onto the Japanese module. So it's from where we are actually capturing this moment. Okay, so good news now. First six of the 12 hatches are closed, and six more to go now. So now we are at the final phase of the docking. As said before, now six hatches have been connected with the Dragon capsule. We have six more hatches to connect with the Dragon capsule. Once everything is connected, the final now the hair between the uh, capsule and the International Space Station has to be air pressurized so that the astronauts can get into the International Space Station. And as I explained before, we are we are in the Russian module. The docking is in the Russian phase, so we are just waiting for the final hatch, last six hatches to connect. Okay, we have an hot capture is confirmed now. Now we have the connection cords to the Dragon capsule, which provides the power and the communication link. So now they are waiting for the connection and to get the connection between the Dragon and the International Space Station. Okay, we now have an official confirmation that docking sequence is completed. We had a soft capture first, and then the soft capture was released, and then we had a hard capture mechanism where 12 hatches from the International Space Station got hold of the Dragon capsule, and then there were cords connecting to the Dragon capsule to supply the power from the International Space Station. Now the docking phase is complete. Now we received an communication from the International Space Station, and the astronauts from the International Space Station are giving an invitation to the astronauts Bob and Douglas. Astronauts from International Space Station are again welcoming Bob and Doug, which is like really great. Now they are actually checking to the ground station. Control is giving a command to the Bob and Doug to check the pressure chute to just to verify um, the chutes inside, the inside of the suit. Now they are making the final checks for the astronauts to enter the International Space Station. Okay, now they're gonna finish. They're gonna go for a pass now. So we have successfully docked. And thanks everyone for joining. I hope Rifat Bro will join us soon. Okay, now so I think new people are joining in now. So we have actually docked successfully to the International Space Station, and then the astronauts are going on the final checks now, and they will check all the pressure and the thermal stabilization, and they will go further. They will check the air pressure between the giant capsule on the International Space Station. And then when finally everything is okay, and the astronauts are going to go to the International Space Station, and then it's a huge success to the space community, and of course to everyone watching here, and who will watch and who are much interested in space, and to all the engineers who have worked in this sector as the space sector. And there have been lots and lots of scientists who have been working for years for this mission to launch an astronaut from US soil again, and then this has been a huge success, and they have docked safely into International Space Station. So all the best for the astronauts over there. Let them have a successful mission, and Godspeed. Let them be safe. And so, thank you everyone for joining the live. And if you have any doubts, please leave it in the comment section. We'll be happy to explain. Thank you everyone. Hello, bro.
Hello.
Hello, bro. Can you hear me?
Hari, am I audible?
Yes, bro. Yes, bro. You're audible.
So, hello guys. Good evening. This is Rifat here, the Chief Technology Officer and Lead Scientist of Space Kids India. We just, finished the awesome YouTube live because I was doing another YouTube live side by side with the Government of India's Niti Aayog. We were, partnering with Atal Tinkering Lab. We were having a beautiful webinar with them. But students were asking a lot of beautiful questions. The session got a bit delayed, and I missed the spectacular docking event of the Dragon. But you know what? I was actually having a TV beside, and I was having a look at the the docking session. Mr. Hari, please, I want you to help me and update me about what are the events happen now.
So yeah, so finally, we had events like from 100 meter, it was closing in really slow at so very slow phase, and then once they were near 20 meter, they had an final check for go no go to dock with the International Space Station, and then after 20 meter, they moved really slow at about 10 centimeter per second, so which is like
Oh,
very slow. And then they took another
yeah.
2 minutes to reach the International Space Station. And then first, initially, they had a soft capture, so to
Okay.
dampen the movement of the capsule. So when it does the soft capture, it's used to
Okay.
dampen the other axis movement of the capsule. And then they finally the soft capture was released, and then they had the hot capture where 12 hatches has to connect with the capsule. So first, initially 6 hatches connected with the capsule, and then the next 6 hatches connected. Now, after which they send the cables for the power connection from the International Space Station to the capsule, and then the hatch between the docking capsule and the International Space Station was pressurized for the astronauts to enter. But we also had a little uh, update from the ground station that there is uh, a slight difference of pressure inside the Doug's suit. So they said like it's still within the marginal level, but they just mentioned to check the interior of the chute before entering into the air module, the air pressurized module. So finally, the final
Okay.
corrections were made and everything is checked. And now we are actually waiting for the astronauts to enter into the International Space Station. We can now see that the on the International Space Station on the other side, the astronauts are getting ready to invade the Bourbon, which is like a great huge moment now.
That is awesome, Hari. That is awesome. So the astronauts, they came out from the Dragon capsule yet or not? So they didn't come out yet.
Sorry, sorry, I can't
Astronauts,
hear you clearly.
have the astronauts came out already, or they're still inside the capsule?
They're still inside the capsule. Still inside the capsule. So
Okay,
they're
so they
waiting
are
for
ready to space.
the fine.
Awesome, awesome, Hari.
Yeah, they're
Awesome,
waiting for the final command to get into the International Space Station.
awesome, awesome. So thank you, Hari.
So
Thank you so much for
that was
hosting
like
the live on behalf of me. So now we have a few bright minds
no,
joining the live here. So we have we know there is a Desi company. We can call it as a Desi SpaceX. We all know Agnikul Cosmos. So the founder and CEO of Agnikul Cosmos, Mr. Srinath, will be joining us on the live panel very soon. And we have Srinivas Lakshmanji, who is a prominent space journalist. He wrote about the space for last 10 to 15 years. He will be joining us very soon. And we'll be having Dr. Srimati Kesan, CEO and founder of Space Kids India, joining us for the today's live session. And we will be also having Ruchira, who is also a prominent, space journalist. And I'm just waiting for Mr. Sanjay Rathi, the founder of SDNX, Space Development Corporation Nexus, also to join, but we are waiting for him. Meanwhile, when he's going to join, I will add rest of the people to the panel. So thank you so much, Hari. Please, join us through the feed and watch us. Thank you,
Sure.
Hari. We'll see you soon. Thank you.
Thank you so much.
I'm adding Dr. Kasan. Hi, ma'am. How are you? So happy to have
Hi,
you here.
hi. Good, thank you. Thank you so much.
Yeah, I'm adding rest of the people.
I hope Srinath is joining,
Srinath is
Irfan.
joining. Yeah, he's joining. I'm adding Ruchira, Srinivas Lakshman, everybody. Srinivas G, Ruchira, everybody's online. We are waiting
Hi,
for.
hi. Finally,
Yeah,
we are
I
able
have
to
some.
see each
I
other.
hope, I hope today your connections are good and we are going to go, hey, we are having the little mouse Srini ji there. Good.
Hi.
So I'm
So, how are
about to
you
give you
feeling?
some quick information about what have happened. So the dragon is successfully captured, but there is a minor pressure difference, inside the pressure suit and the capsule and the International Space Station. So they are going for the final go no go, and they are preparing the capsule and both the capsule and International Space Station, ready to welcome the astronauts inside. The Dragon capsule is successfully captured. It's successfully docked, but they are just thinking about this small pressure variation, even though it is
Yeah, they're
under the
waiting for the
marginal level.
unlatching of the door. The
Yeah.
Yeah.
unlatching
So
of the
even
door,
though,
which is
yeah, ma'am, yeah, correct, yeah, correct, ma'am, correct. So the differences are under the acceptable level. So they'll be soon fixing all those stuff and opening the latch very soon. So meanwhile, Mr. Srinath will be joining us in just few minutes. I will go ahead and ask Mr. Srinivas Lakshmanji, because
Yes,
yesterday itself, I was very sad that I was not able to talk to him. Hello, sir. How are
yeah,
you? And how you are feeling right now?
that's okay, but the program is very good. Beg your pardon?
How you are feeling right now? So we have successfully
Hello?
docked yesterday. Yesterday we had a very beautiful
Hello?
launch. Now we have successfully docked. So how you are feeling right now?
Hold on,
How are you
fantastic, top
feeling?
of the world, a new launch, a beautiful capture, soft capture, a giant leap for space program tonight. It's a giant leap.
Yes.
So that's what I would call it, and it opens a new era in the world of space exploration, manned space exploration. And I think it's a very great achievement, and hats off to SpaceX and NASA. And interestingly, it has taken place just a few days after Nirmala Sithuraman announced the opening of
Yeah.
the space sector in India. So it's a
Yeah.
coincidence and a great moment for India too.
So Mr. Srinath has joined the stream. I'm adding him to the stream.
Yeah. Next. Uh,
Hello, Mr. Srinath. Welcome to the live feed with Space Kids India. We are so happy to have you here.
Hey, hi. Thank you. Thank you so much for inviting me. Thanks. Yeah, it's great. It's great to be joining you all on a day like today, unforgettable day.
Yeah,
I
yeah.
mean, you
So
are
I'm
the
handing over the
rocket.
session to Dr. Srimati Kesan.
Sure.
Hey,
Please go
Srinath,
ahead.
hi, how are you?
Yeah, I'm doing fine, ma'am. How are you?
Good, thank you. So when we see SpaceX and when we see Dragon, I was only reminded of Agnikul's rocket. The rocket man of India, Srinath, should be here in our session. So that's why we thought we have to drag you here and make you speak about your experiences and how you guys are building this and how young your team is. We want to hear it from the horse's mouth.
Oh, sure. I think that's it's definitely. I'm honored to say that when you hear about these bigger players, you are reminded of Agnikul as well. So Thanks a lot for that. I hope we'll continue to keep the work going to such a level that this will keep coming in people's minds. So yeah, we are a very young team. We work out of IIT Madras. We are about 40 people today. We've luckily been, initially it was all like unpaid internship and so on, but we recently raised a little bit of money, so we're able to pay people and keep them also happy. But other than that, it's a bunch of people who are super excited about anything about space, right? That is what brought us together for the first time. The founding story itself is I was in New York. I was doing something in finance, even though my real passion was aerospace. And then the SpaceX bug kind of got to me. This was back in 2012 or something, which is when I first started following SpaceX. They were doing something here and there. Once in a while, a launch. There were very few people following them at that point in time. They were more of just a California thing. That's it, right? But because I was in the US at that time, I think I had a little more exposure there. Started following it, and suddenly everything
What
started.
happened? What is the problem?
Hello?
Yes, Srinath, please go ahead.
Yeah, can I continue? Sorry, was there a
Please
problem?
go ahead. Please go ahead.
No problem. No.
Okay. Yeah, and then so that happened, and then realized that I have to quit my other things and just have to do something in aerospace. So moved to Los Angeles, which is where actually the real hub of space is in the US. And from there, I got to understand, just spoke to a lot of people, and then understood what might be a few problems that the industry is facing. It was very interesting that everywhere I went, I saw there was one small sat waiting to be launched, right? And whenever I asked people, okay, why are you not launching it? The only answer was SpaceX is backlogged, right? So it was like interesting to me. I was like, everywhere there was some version, like so many people were able to attempt doing small sats, right? But they were not able to actually go to the end and actually see it in space, which is, I think, the completion, right? So then that is when we thought, okay, why was SpaceX backlogged? Because they had their bigger missions to go, and for a small sat, it was just not flexible enough to send like their own small sats with like a big satellite. So there was this waiting time. Uber was not very efficient in space. That is what I figured at that time. So we thought, okay, let's not go with Uber. We just build an auto. If there is no bus to go to space, let's build an auto to go to space. And that is how the small launch vehicle story came up. So what we are building is a really small rocket that can take anywhere between, somewhere less than 100 kgs. And we wanted to specifically focus on having no waiting time. If someone has 2 kgs and they want to put that in space, we said, okay, we can put that in space in like a month for you. That was the idea. So we decided then to make it commercially viable, right? It should be a business also. So we decided we'll have like a plug and play configuration, like Lego blocks, right? You don't put all the engines at the same time. If you have 100 kgs to take to space, you put 7 engines. If you want only some, say 10 kgs or something, put only 3 or 4 engines. So we started with that core idea and started configuring the rocket and so on. Again, all of us were like fresh to rockets, right? None of us had really built rockets before. So we started playing with this idea, and slowly with the support of IIT Madras and with ISRO scientists who have retired and current people, we slowly are able to now converge on a configuration that can scale. So if there is a 10 kg satellite, we can scale it for 10 kg. If it's 100, we can scale it for 100. So that is what we are building. So from US, when I started thinking about all this, then I cold called a lot of people in India. And Professor Satya Chakravarti from IIT Madras, he was actually interested at that time. So I was just pinging him from the US, and he was still nice enough to actually listen to my idea. And he said, okay, I can support you if you want. And once that started, I got my one supporter here. So came back to India, and then since 2017 October or something, I've been in India doing only this full time, and it has been a great journey.
Wonderful, Srinath. Wonderful, Srinath. Yeah. So we pray that your Uber auto takes off very fast. With a lot of
we'll get.
We've got a space enthusiastic journalist here with us. I'm not sure if you were, if you were introduced, Srinivas Lakshman. And he's the senior most space journalist.
Nice.
Yeah, he's met, I think, Buzz Aldrin, and he's met so many of them, and he breathes in space. So that's why we have him here.
Awesome.
We thought it would
Awesome.
be wonderful if you guys also interact together, and if you had any questions also to be spoken. And we have a beautiful young lady, Ruchira, who's entering into the space arena. She
Hi.
a BSc grad
Hi.
and working on ground systems and everything. So now entering into the main arena of space.
Awesome.
So we
Awesome.
have a wonderful panel here now. So
Nice
what is
panel.
in mind? Srinivasji, you've been looking at the docking and you think there is some hitch there, and what is running in your mind now? Are these guys going to enter in, or no? They're going to be the entry ticket is banned, and they're going to be standing outside in the queue for some more time.
Srimati, space is unforgiving. Space is unforgiving. Hello.
Yes, we can
Yeah,
hear you.
yeah, we can hear you.
What did you say? I can't hear you.
No, we can
We
hear
can
you.
Go
hear
ahead.
you. You are audible. Go ahead.
You asked me what is the hitch. There is a pressurization. I mean, there is a lot of disturbance in the communication. It's not. I believe that there is some pressurization problem which is being sorted out, and I'm sure in another few minutes things will be sorted out.
Wonderful, optimistic as ever. He's our lucky mascot.
Definitely, definitely. So the thing is, like initially
Okay,
they
go
had
ahead.
a soft capture. Initially they had a soft capture. Now
Yeah,
it is
Yes.
one has in space. One has no choice but to be optimistic, as Ruchira was just telling me a few minutes ago.
Yeah.
yeah, yeah.
Yes,
So I
Ruchira.
was,
So yesterday you
I was
joined us
telling
during.
him what?
Yesterday, Ruchira, you had joined us during the launch, and today, how was
Yes.
it to be here during the docking?
It's amazing. I mean, like we were saying, we were optimistic then also, and now also we are optimistic. And space is all about hope, I think. So me and Srinivas sir were discussing before this live thing now about this launch itself. So on 27th of on 27th of May, when this launch was supposed to be happened, we all were sitting there and like hoping for the best, and we all were seeing, till last 18 minutes. We all knew that maybe this is not going to happen, but we all were like sitting there and hoping, and till last minute we all were like hoping for that miracle. And yesterday also we all were sitting like that. I mean,
I have a
though
quick
there were
update from the Mission Control Center.
people who
So
said that
now you might have seen on the screen that astronaut is connecting cables to the hatch. So they are getting prepared to they are getting prepared to open the hatch very soon.
yeah.
So the positivity, the positivity of having
Yes.
Srinivas, I think, working, I guess. Yeah.
Yeah.
Please go ahead, Ruchira.
So, Srinath,
Yeah.
coming back to you now. Srinath, we saw the sophistication inside the capsule of Dragon. I mean, it was like sitting in a first class flight,
Yeah.
first class flight.
Yes.
So do you think, are you guys also building something like this, so that we can flaunt off saying, everybody, look, at economical pricing, India has built the best of the rockets?
Definitely in the plans, but not at this point immediately, right? So actually, let me do one thing. I'll see if I can share my screen or something with an earlier image from SpaceX. This was when SpaceX was a startup, right? You're looking at, say, around 2006 or 2007, and you look at how basic and rudimentary things were, and that was how they proved their first orbital flight. Right.
Yeah.
If I just for some reason today I've not been able to share my screen. If that is the case, then I will actually paste the link in the chat here. Can you all see it if I put it on the chat here so that you can all open
Yes.
it yourself?
Yeah,
Yes.
please put it in the chat, and I will mirror it. I'll do the screen.
Yeah, I think that might be better because so I don't know how many of you know this. In the current SpaceX website, there is a section of blogs that Elon Musk was doing with his team way back in 2005. And
Yeah.
I would encourage everyone to go and read it if you've not, because it's like super simple. Anyone can understand. You don't really
Yes.
need to be like a rocket scientist. And more importantly,
Yeah,
he
it is
talks
getting unlocked.
they, like day-to-day failures they've had and how they're going to, deal with it and so on. So to answer your question, ma'am, that is closer to what we're targeting right
Wow.
now. But yes.
1 minute.
Is it
The
all?
hatch is open right
The
now.
hatch is
You
open.
can see the screen. Yeah. So the internal door is right now open.
Yeah.
So now we
Yeah.
have to. Yes, 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 yes. The moment we all have been waiting is right now here in front of our eyes.
Yes.
The hatch is open. So he is running. He's quickly running some cables.
Awesome.
Yes, Srinath, go ahead. Go ahead.
Please
Sorry,
go
I
ahead.
think in
Oh, no, no, no. This is what is
all these
happening is
exciting moments.
way more important than the
Yeah.
talking about last time. So I just put a link on the chat. So whenever you can, just look it up. Yeah. So that is sort of like what we are trying to, like, to build as a first piece of hardware, right? A simple system to get it to work. Once we prove the point that we can go to orbit, then other things will automatically follow.
So now, Srinivas ji, question to you. I mean, in this
Once we
pandemic,
prove the
also
point that we can
America
go
has
to orbit,
proved
then other
something.
things will automatically
Where is Indian space research now? Are we a go,
Yes.
or is it going to take some more time to come out of this pandemic?
Beg your
And
pardon, I can't hear you.
Srinivas ji, can you hear me? Can you hear me?
Of the uh, Shrimati, can you
Srini, can
repeat
you
your
hear me?
question because there's a lot of disturbance.
Sure. I can repeat that for you. In this pandemic, in spite of topping the list of deaths, still America is done something
Yeah, but it's a
phenomenal.
broken voice is getting cracked.
Rifat, I think you should help.
Srinivas ji, can you able to hear me? So, ma'am is asking, like, despite
Yes,
this pandemic,
yes,
despite this, COVID-19 and all this stuffs are going
it is
on,
done. Yes.
yeah, America is still able to, like, successfully able to launch these two astronauts into
And
space.
now you are
So,
clear. Tell me.
yeah, so ma'am is asking, like, what you think about the effect of,
Yes.
this pandemic on the space
Pulled
industry?
it off. They pulled it off.
No, Indian space
Yes.
research. What do you
Yeah,
think?
Indian
What do you
space
think?
research. The effect of pandemic on Indian space research.
It's a fantastic thing when the world is. 1 minute. Let me
Effect.
finish. This global crisis,
Hmm.
pandemic or Indian space research, I think in India they have temporarily it has stopped.
Hmm.
What? No, I think
So what
despite the
is the
pandemic,
effect?
US has pulled it off. I think hats off to them. In fact, next month again, July 18th, they are having this mission to Mars. Again,
Yeah.
it's going to be yes.
So
Hello.
ma'am is asking you what is the effect of this pandemic on Indian space
Yes, go
mission?
ahead.
I think there's a delay for Srinivas ji.
Yeah, it looks
So,
like that.
I think you both of you guys can join together.
Yes, Ruchira. So, what do you think? Probably you can answer that question. So, what do you feel?
I say
So
we are not able to communicate here only.
that's true. The space is the another thing.
Oh
Yeah.
my God, these guys are making it look like
Hello.
a seriously with all the slings and
Mission
everything.
control. We are not able to hear anything what you guys are saying.
I think
Hello, can you hear me?
mission control team
Can you
again is
hear me?
having some problem, I guess.
Yeah.
No, it is
So
mission
I think
control
it will
Mumbai,
take
ma'am.
some time here at
Yeah,
least. Though
yeah. Please,
private
Ruchira, you
sector,
go.
Yes, Ruchira, you go
yeah.
ahead.
So at like though Nirmala Sitharaman ji said, like as she said, private sector is now taking part in this mission. But I think for this Gaganyaan and all, we will be delayed by some time because this training is also on hold now, and we don't know when it will start, right? So it is going to affect Indian space program in some ways. but the hopefully, the again optimistic
Rifat, we've
side here
lost.
is
We've
the
lost.
entry of. Can you hear me?
Yeah. Please go ahead,
Hello.
Ruchira. Ruchira, we are able to hear you. Please go ahead.
Okay. So I was saying the optimistic thing here is the entry of private sector in the space. So I think with the private sector, we will do some new things here.
Wonderful. So now, Srinath, we've lost Srinath, or Srinath is there, Rifat?
Yeah, Srinath, please come online. He just turned off the mic and camera.
Yeah, I'm here because
I'm
my
not able
bandwidth
to
is
see
also
him.
not great, so that is why I
Okay.
just turned it off. Yeah.
Okay.
Can you see me and
Yes.
hear me now? Everything is
Srinath,
good.
I
Yeah, we
wanted
can.
to ask you something. So,
Sure.
what is the estimated timeline that you're looking for launching your rocket?
So if all goes well, somewhere between 2 to 3 years, right? We were actually planning to do it within a 2 year time frame. However, this goes back to your previous question, right? The impact of this lockdown and stuff. So obviously, supply chain across the world has been a little impacted. So because of that, there is a delay. So hopefully, 2023, somewhere between 2022 and 2023, in that time frame, we'll be able to do it.
Fantastic. Okay. So, really look forward
So
to that.
Srinath, being in this field, what do you think? How is it going to affect pandemic? How is pandemic going to affect Indian space program? What is your opinion on that?
So things will have to be a little slower, right? Obviously, I think already I've
Yeah.
heard from a couple of people that there is actually one. Uh, there was one. I think the second stage engine, the Vikas engine of PSLV, it was like waiting to ship to Shar and
Hmm.
Sriharikota, and it was not shipped because they were just of the lockdown, right? So those
Oh my
kind of
God.
delays are going
Yeah.
to be there.
Yeah. Yeah.
But I think we will figure it out. I think a lot of people have learned to work from home and get as much productivity as possible from home. So that part
Yeah.
would still happen with ISRO as well, I think.
Yeah.
Yeah, this will be a little bit of a delay. But I guess it's
Yeah.
almost globally a delay for everyone, so it's okay. All right.
Yeah.
Is
So I have
the
a question for
rocket?
Mr. Srinath.
Yeah, yes.
Uh, Mr. Srinath, like when getting into this, all this rocketry development, initially, even if it takes SpaceX, we concentrate on the development of engine, development of propulsion system, and everything. So I want to. It will be interesting if you can share like how advanced your avionics systems are. Like are we manufacturing them here in India itself, or are those like completely designed here by Agnikul itself? And will we have the capability of vertical takeoff and vertical landing somewhere in the future in the Agnikul rockets?
And added to that, one more thing: is it reusable?
Yeah, that's the holy grail of the launch industry now, reusability, right? Yes, so to answer your questions, reasonably sophisticated, but not too complex to a point where it is unnecessary, right? So we are starting off with the usual approach that many startups take, wherein you build just enough to get that first vehicle out, right? But at the same time, even that, what they call usually the startup jargon for this is minimum viable product, right? Some of you might have heard it. So whatever the most meaningful amount of innovation to be done to make something work, that we are definitely going to do. That itself, we are doing it with commercial off-the-shelf products. So it's not like you need to get. See, the interesting thing about a rocket is it actually spends anywhere between 15 to 30 minutes in flight. That's it, right? I always tell our team also. We've been working for 5 years. I think at the point when we'll launch, we'd have been working for 5, 6 years, and then all of that work is going to be mattering only for 20 minutes. Just like yesterday, you saw this, right? The build up to the launch and the launch phase itself was like so small. So there is an advantage to that. The advantage is that even though there is radiation in space, there are usually space hardened stuff is required for most space applications. For rockets, it's not a necessity. If you have enough capability to detect failures and have some redundancy, you can actually fly with normal components just packaged a little better. It is not the case for a satellite. Satellites are different. Satellites have to be in space for a really long time, so they're more prone to radiation
Yeah.
failures. Rockets are not like that. So we went to the electronics part of it. We took the simplest possible functional version of these products, and we just said, okay, we'll manage it in software. So the thing, what we want to build is more like is more like an iPhone, right? That will fly to space, right? You go with the most high quality, affordable product that you can take, and build in all the functionality on it, and the rest of it take care with software. And that is possible today. This was obviously not possible in the 70s, 80s. SpaceX actually did a lot of it for their rockets. If you look at it, it is actually a flying robot. SpaceX's rocket is actually more like a robot that goes to space. So that is a great way to think of a rocket in a 21st century context. That is not how rockets were when the Apollo missions and all that. It was not at all like that. There it was more like tanks, engines, valves, all these things were flying together to space, right? That is how that was mechanical hardware flying to space. Today it's like a phone with engines flying to space. So that's how we are thinking about it.
Well said.
That is true.
Well said. Well said. And what about the fuel that you are thinking about and working on, Srinath?
Kerosene and liquid oxygen, semi-cryogenic combination.
Okay.
It's easily available.
Why
Also,
people haven't went with the traditional, solid rocket motors? Because that will be more easier to build, right?
yes, solids are easier in the sense they actually have less plumbing, right? You don't need to put valves and pipes. But if you look at it from a flexibility standpoint, actually it's an explosive. It's a bomb waiting to go off, right? So any small mistake you do during transportation or during fabrication, that will have a disastrous impact. And also, it's not easy to transport it from one place to another because the whole thing is waiting to go. As opposed to liquid propulsion systems, like for us, it is like the analogy is like you're just taking an empty car without the fuel in the car from one place to another. It is super benign, right? You can actually sit next to it and travel with it if that has to be done. So it's that straightforward to transport. So that was one reason. And the other reason was that we wanted customizability. So at some point, a lot of you asked about reusability, right? So we want to attempt that too at some point, not our first product, but definitely down the line. And for that, solids are not going to be enough. So we thought instead of perfecting solids and being super safe and trying to focus on that technology, which is not customizable, we will take liquids and actually get used to that right away, because that is how it is easy. That's how it's going to be easy to scale. And a large part of the complexity of liquid rocket engines can be eliminated if you use things like 3D printing. So what we did is we made like a engine that is one piece 3D printed. It's almost like you load the CAD file into the 3D printer and you wait for about 38 hours or something, 38 to 40 hours. And then you open the printer and you will see the full engine there. So that is something that we are using to eliminate the complexity of having so many pipes and walls.
That is awesome. That is really awesome.
You have your 3D printer?
We use the ones in IIT. That is, and we also have a few vendors who use it. So these are again, the innovation is not about the 3D printing concept. It's about the design. It has been designed such that the whole rocket engine is a single piece and it's 3D printed in one shot.
Yeah. So we used to use 3D printed parts for our ground station program.
Nice.
So,
nice. Very
so all parts when right from the holders till everything. So you just reminded me of that.
Good. Nice.
Yeah.
So to the interesting young people who are watching this live, what would you like to tell them, Srinath? A 1 minute from you, some takeaway for them.
I think there is no better time to be a young person than today, right? There's so much awesome stuff that was only considered science fiction is happening in front of our eyes, right? This is amazing. I can't believe that already so much of science fiction that I used to read has gotten converted to reality, right? So I think dream big is going to be my first thing, and just keep following your dreams. I think there will be distractions as you go through life. You might want to do something because of some compulsion. We might have some peer pressure. We might have some parental pressure, whatever. But if you have a real dream and you really put your heart to it, even if the path is a little rough in the beginning, I think you will get there. At least that is how it has worked out for me. I wanted to be an aerospace engineer. My parents said, okay, you'll only get a job in ISRO. And even that might not really happen quickly. So do you really want to do this? Go to electrical engineering. So I did electrical, and then finally, when I was financially independent, sort of came back to aerospace engineering, quit everything. So I think the only thing I learned from that is, okay, I should just always followed my heart. My parents they are still actually supportive of my idea a lot now, right? At that point, they were also nervous. They didn't know what was going on and all that. But with SpaceX paving the way for every private player to actually think of space, this is the time to be a space enthusiast. Literally, what will happen, I'll tell you, right? The future looks super bright. I think with SpaceX doing this, everyone is going to, be involved in space. So getting to space is going to be super straightforward in maybe 15, 20 years. It's going to be like a plane, right? You're just going to take a flight to go to some place. That's how it's going to be. Maybe 15, 20, okay, worst case 25 years, right? And in this process, what will happen is people will start thinking about what to do once you get there. Right now, the problem is getting there. So a lot of focus is on rockets and talking, like all of these things. We are actually talking about mechanism of getting from point A to point B. But I think soon that will become about living in space, about building stuff in space. So yeah, I just feel like whatever crazy dreams you might have will soon become less crazy. So keep having those dreams and keep following your heart. That is, I took more than a minute, but that is what I wanted to say.
Oh, no. You spoke your heart, and that's what is required here for the children who are actually watching, because space people think is not very affordable, and you cannot reach out. So for even though they have the passion to study space, they end up doing something else just for the monetary benefits and everything. And Indian parents, as you rightly mentioned, a secure position, a secure living, that's what they look at, and dreams are always a far off thing. So it was very nice that you spoke. You went on a U curve and you just got back to your passion. So, and you built in a good team who's supporting you. So good luck to you, Srinath. Thank you so much for
Thank you,
having
man.
you here.
Thank you.
Thanks for your time. Thank you very much.
Thank you.
Thank you, Srina. It was awesome having
Thank
you
you,
here.
Srinath. It was nice connecting with you.
Thank you. Thank you very much.
We will definitely keep in touch offline as well.
Absolutely. Yeah, definitely.
Yeah.
Always happy to speak to any space enthusiast. Even people who are watching, if you want to reach out to me, definitely do. I would always love to chat with any space enthusiast anytime. Sure.
Okay, thank you,
Wonderful,
Srina. Thank
Srinath.
you.
Thank you.
Soon I
Thank you
hope
so much.
Space Kids India satellite will be flying on board Agnikul rockets someday in future. I am really looking for that day. Thank you.
In fact, Rifat, that's what I said when I went to
Love to
meet
do
them.
that.
I think in December I came there and I met a couple of guys
Uh,
there along with Dr.
yes.
Shankaran. And that's what I said. Our next satellite will be flying, one day with you.
Sure, ma'am. Definitely.
Thank
Thank
you.
you,
Thank you.
Srinath. Thank you.
Thank you.
Bye.
Okay, bye-bye.
So it's
Yes,
Srinivas
Rifat.
here.
So what's happening? Still the guy, still the
Uh,
customers are still
yeah,
not
ma'am.
coming. What happened?
So there is also a temperature change, temperature difference as well. So yesterday itself, you might have heard that yesterday I was watching the live because most of the people they turned off the live, but I was tuned in, to the live till morning around like 5:30 a.m. So NASA was actually conducting conference, and there was one question from a press in UK. So someone was noticing the mission controls audio feed very carefully, that they noticed that there was a glitch during the launch. So there was a temperature sensor glitch during the launch. The sensor was sending different kinds of data than expected. So
Yeah.
there was a no go for some time, but then they figured out and they launched it. But now, again, once they were in orbit, astronauts were, calling the mission control center and asking. They were carrying two thermal cameras, and they were asking that some kind of LED started blinking without, unexpectedly that LED started blinking. So after some discussion with the ground control confirmed that is completely normal. That is not at all a problem, but it will take around like 1 or 2 hours to reach the thermal equilibrium. So that is what happening right now because the ISS International space station is at different temperature, and the Dragon capsule is also at different temperature, and the pressure is also a little bit different from here to there. So both the crew inside the International Space Station and the crew inside the Dragon capsule are waiting for the temperature to reach a equilibrium, and also fix the pressure difference, so they can enter the International Space Station without any problem. And there is we may be questioning why it is very important, that is going to be a few degree difference, or the pressure will be very small, the difference will be very small. But today at around like 4 o'clock, I was again watching the live feed of SpaceX, and during that time itself they actually temporarily opened the hatch. Hatch is having two layers. So inside we are seeing the latch is still open, but this outside structure they opened at around 4 o'clock itself, because they told in the space the carbon dioxide the astronauts are breathing out. The concentration might be little bit higher. So when they suddenly open the latch, the astronauts inside the capsule should be suddenly start feeling hard to breathe. So they are making sure the process of transferring whatever the situation here and there. So they want it to slowly happen and become equilibrium, the temperature, the composition level of atmosphere, everything to reach same level, so they can peacefully enter the space station. Right now on the screen we are looking, the astronauts are carrying the tools to open the hatch of the Dragon capsule also. So right now, that is what we are looking at the screen. We are having three astronauts on board ISS right now, two Indians and one American astronaut on board the space station. So I think it will take some more time for the astronauts to enter the International Space Station, because they just now they turned off the light as well. Well, I hope you are able to see the screen. Just now they turned off that light also. So I think it will take more than 30
10:15
minutes.
in the night, I believe.
Yeah, 10:15 in the night, I think.
Yeah.
What about Sanjay Rifat?
Yeah, ma'am. So he is not able to join. He is offline. So
So
I'm
that is
not
what the
able to.
schedule says.
Awesome, sir. Awesome. So I
Srinivasji,
think
you're able to hear now. You're able to hear now. You're able to speak, right?
Yes, yes. And Srinivas also, yeah.
right now on the screen we are
Who's
having a
this?
beautiful, spectacular view of
I'm
Dragon
okay. Tell me, go ahead.
International Space Station.
Rifat, go ahead with
The dra-
Srinivasji, the lucky mascot of space industry.
Yes, sir. So I hope I hope that finally Srinivas ji is able to join us today.
Yeah,
So
go ahead. Why are we pausing so much?
yeah, what you like? Starliner versus Dragon. Which one you like the most and why?
I have joined you. Well, I've answered one of your questions also. Uh, Can you repeat your question?
Starliner versus Dragon. Boeing
Rifat, can
Starliner
you repeat
versus
your
Dragon. So which one you like the most and why?
going?
Why?
Uh,
Why, sir? That is really
Yeah.
surprising. The
How can we
whole
answer
world
that question? As of today, Dragon has pulled it off. Starliner unfortunately didn't make it into the orbit. Poor thing, why should we compare the two? Yeah, it is like having two kids at home, and you can't say this one is better than that one.
Exactly my point. Exactly my point. We should
All
not
are good.
compare these two.
Unfortunately, the Starliner did not make it into orbit. So it will do, and I'm sure both are very nice.
awesome.
Yeah. I don't think you should compare and say this is better than that. I don't think even in SpaceX and Boeing, they compare and say mine is better than you. It is real luck today. Dragon made it. I'm sure they will also catch up.
What do you think about the Gaganyaan mission? So when is it going to be pulling off, Srinivasji?
How closely we're to hatch opening or another timeline milestone. We're kind of running to the end of the tablet here with.
Well, you're asking me, Srimati?
Yes,
Gaganyaan
go
mission,
ahead.
yesterday Mr. Shivan said many missions have been postponed because of this COVID-19.
Yeah.
And the training, I believe, has started in Russia for the 4 Indian astronauts. Now, hopefully, it should go on schedule, but if there is a delay, it is understandable.
Okay. So what will be like, we had quite a number of launches, PSLV launches lined up. So do you
Hello?
think it's going to start off anytime in the
Hello?
near future?
Space station now, huh?
Indeed. Thank you so much. We're excited to be here.
Yes. No, yesterday or day before, Mr. Shivan told the media that most of the missions are rescheduled now. Now, when is the next launch?
That we don't know.
Chandrayaan 3, many things are rescheduled. Aditya was supposed to be this month, that is rescheduled.
Yeah.
Okay. Yes, go ahead, Rafat.
Yeah, ma'am.
Okay.
So on the screen, we are having a beautiful look of the Dragon to successfully dock with the International Space Station. So, like Srinivasji told, I think it will take 1.5 hours to open the latch and the crew to get transferred to the International Space
Yes.
Station. So they are running the checkup. So the flight surgeon is talking with the astronauts. So they are running all the checks. They are
Hatch.
making sure everything is, you know, and I want to ask Srinivasji an interesting question. That yesterday Doug and Bob they named the
Yeah.
capsule Endeavour. They named the capsule Endeavour. What do you think about this?
They named the Dragon spacecraft yesterday?
Yes, they
Yeah,
did.
yeah, because
Hello?
right from the days of Gemini,
Hello?
it's a tradition for U.S. astronauts to name their own spacecrafts. Uh, whether
What
it
is the
is
question? I mean,
Dragon or
you're not
Endeavour.
clear.
So
The
the
reception is
astronauts given a pet
very poor.
name the spacecraft.
Right from the days of what?
Right
Ma'am,
from
please
the
go
beginning,
ahead.
right from the
Rifat, you're
Apollo
directing the
days.
question to me or any whom are you asking?
To you, Srinivasji. To you.
Yes, ask, but your voice is cracking. That's what I'm not able to figure out.
Rafat, ask again. Probably he's able to hear you.
Or ask slowly, and because the voice is cracking a lot.
So Srinivasji got disconnected. I think there is some bad network problem there. So Srinivasji got disconnected. But I really hope we should add Srinivasji in at least the next session with proper internet. I think I should call whoever the nearest broadband network the service provider and give him a better internet connection. Yeah. So Ruchira, please
Yeah.
tell what you think about this.
So achieving something with with struggle, and that is something which it means, right? And this mission is like this mission highlights that, because the way they have done it, and after so many trials and all these things. So I think that name is very much suitable, and I really like this is really commendable. I really like that name when I saw it.
In fact, there was an interesting fact also mentioned by Bob and Doug. They were both on Mission Endeavour, And they said
Yeah.
it was almost 8 years and we were waiting when we were going to get
Yeah.
back to our little home there up.
Yes.
So that's
Yes.
why we thought we should definitely give the name Endeavor. And the
Yeah.
description was so beautiful.
Yes.
And along
Yes.
with the description, I think the dinosaur was also very beautiful.
Yeah.
And they're going to be having subsequent launches also. And
Yes.
what do you think their mission time would be, 1 month or 4 months? What do you think, Ruchira?
I think 2 months, right? They were talking about it.
They were talking about one anywhere between 1 and 4 months.
1 and 2 months. 1 and 4 months. I
four
think
months
2 months
yeah.
they're planning. Yeah. Because
Okay.
yesterday me and Shrini were discussing this thing, like when this next thing will happen, and we came to this number. Like after 2 months, I think this thing will happen.
Oh, the re-entry and the launch will again happen
Yeah.
after 2 months. So we'll get
Yeah.
back all the speakers again and we'll have a good interaction session again now.
Yes. Yes.
I
Yes.
think we'll have to cut the cake again.
Yeah. And hopefully that time we will be like, we will meet each other and do it.
That's wonderful. That's wonderful. But I think I
Again,
lost
optimistic.
Rifat also.
Yeah, I think we lost
I
him as
lost
well.
Rifat also.
We lost both of
I
them.
don't understand. Everybody vanishing, and I think everybody is wanting to help open the hatch.
Yeah.
One fly Rifat, one fly Srinivasji. Everybody is flying away.
Should we both also go and join them?
I think so. I think so. Looks like. So, what do you
That
think,
would be fun.
Ruchira, would the family be feeling now? Sitting back and watching Bob and Doug's family. What do you think they must be thinking?
I think so much proud, and at the same time, there will be like mixed feelings, which we really cannot even understand. Also, I mean you have to go through that to explain it. I
I know
mean
if you
we
were a
are
kid,
sitting
if you
here,
were a
and
kid and
I
if you saw
remember
your
Alex.
father traveling.
Yeah, and I remember Alexei Leonov, who is the first person who had like space work. So he has written one book, and I was reading that book, and in that book he has like he has explained everything. So how his family was going through, and how his a young small daughter, and she was like a few years old, and how she was crying at home, and how his parents were so panicked and all those things. So when I was all those things, I was trying to imagine it. Okay, I have read so many biographies by all these astronauts, but each and every time I try to imagine it, but I fail in that because it is something which you have to experience, and we have never experienced it, right? But
Absolutely.
there will be a mixed feeling, but I think both of their wives are astronauts, so they know what happens there. They have that idea, and they have that they have experienced it by themselves. So their feeling will be much more different than other wives of or other family members of other astronauts. That
I
is
think
for
like
sure.
in spite of 4 times travel, these
Yeah,
astronauts, I think each of them have traveled to space 4 times. In
four
spite of
times.
that, I think the family will be feeling, every time it's a new one.
Yes, yes,
But anyway, they are doing a wonderful job, and I think
yeah.
man needs to
They're
explore
creating
space.
history.
So,
They're
on behalf
creating
of all of
history.
us, on behalf of such million people, I think
Yeah,
they are representing us and they're working there and creating wonders for us, exploring space. And
yeah.
thank you, Ruchira. I think, we had a
Yes,
lovely session. Now we will
yes.
enjoy watching opening the hatch and
Has,
the
yeah,
astronauts
yeah.
getting in.
Yes.
Thank you. Thank you. Thank you,
Thank you.
Ruchira.
Bye. Bye.
Bye.
Take
Bye.
care. Bye.
There has been some network problems. So yeah, the International Space Station has been successfully docked. It successfully received the Dragon spacecraft. So yesterday we had a beautiful launch of Dragon capsule, and today it successfully got docked with the International Space Station. We had some good panel discussion today, but we had some network issues due to this all the lockdown, and we are hosting all these events from right from the home itself. The network problem, it's become a big of a more of a problem nowadays. So thank you guys. Thank you so much for joining the live today. This is Rifat here from Space Kids India. So we'll be soon, updating you guys with what are the programs we are going to do, what we at Space Kids India are going to do. So stay tuned, subscribe to Space Kids India and hit the bell icon. So you'll be having continuous update about whatever the programs and events we are going to conduct. So stay tuned, guys. Thank you so much. See you soon. See you also.